So hello to my sweet daughter. In this video we'll learn about matrices.
Yes.
So instead of learning about matrices by definitions, we will do examples, and with example we will learn matrices. So a matrix looks something like this. And I have broken my chalk. So it's like 1, 2, 3, 4. This is a matrix, right?
51.
So each matrix has a dimension. So a matrix has dimension. So dimension is that this matrix has some rows and some columns. So you can say this is row number 1, this is row number 2. So it has 2 rows. So we can say 2 because first we count rows, and then it has columns. 1 column and 2 columns.
Can it be
So,
like 1 row, 1 column?
Yeah, it can be, but we will come to that later on. So it is like 2 rows and 2 column matrix. Make sense? So now let's make a new matrix. So we have another matrix here. This is like 1, 0, 1, 1, minus 1, 2, 3, 1, 1. So what are the dimensions of this matrix? How many rows it has?
3 rows and 3 columns.
Very good. It has a dimension of 3 times 3. So we do another example, right? In this example we have like this. 1, 0, 1, 3, 9, 7. Now what about this matrix? How many rows and columns
2
it is?
columns and 3 rows.
So it has, no, that's wrong.
3 columns and 2 rows.
So rows are counted like this. So it has 1 row and 2 rows. So how many rows it has?
2 rows and 3 columns.
So it has 2 rows and 3 columns.
Okay.
Right? So these are dimensions of this matrix. So a matrix can also have a 1 row or 1 column. So for example, if a matrix is like this, 1, 0, 1, then what are the dimensions of this matrix?
1 column and
Now first we count rows.
right. 3 rows and 1 column.
So it has a dimension of 3 times 1. Now such a matrix which has 1 column is called a vector. So these are matrices. This is also a matrix, right? But it has a special name. We call it vector. Vector. So what is a vector? A vector is a matrix which has 1 column, right? Similarly, if a matrix has same number of rows and same number of columns, for example, this matrix or this matrix, right? Such a matrix is called square matrix. Because it is a square. It is a square. Same number of rows, same number of columns is a square matrix. Yes. So such a matrix is called
Square.
So far what we have, what we know is number 1. What are the dimensions of a matrix?
The column
Right?
and rows.
Dimension is rows times columns, right? Second thing we have learned is that what is a square matrix, right?
Which is a S for
So a square
equal
matrix,
number of numbers.
yes, a square matrix has equal number of rows and equal number of columns. So a square matrix is of the form n times n, same rows, same column. If it has n rows, then it has n columns, right?
Why n?
Usually we use n, but we can use any other number. You can say m times n. It's like a variable. No? You can put any values in the n.
Okay.
And third thing we have learned is about a vector.
A vector has
So what is a vector?
3 rows and
No.
1 column.
Wrong.
No, like which is has 1 column only.
So vector is anything which has 1 column and it can have any number of rows. So it is like, how can I write this in this notation, in n notation?
It will be like
First rows and then columns.
1 column.
But how many?
R.
But R.
Like 1. Oh, divided by 1.
So it is like n rows and one column. Okay? So if everything is clear?
Yeah.
So now let's clear the board and we'll proceed further.
Okay.
So let's continue with the matrices. And so far we have learned about dimensions and what is a scale matrix and what is a vector. So we can also add and subtract matrices. We can also multiply matrices. So now let's first learn about how we can add and subtract matrices. So instead of going by the definition, we will learn once again with example. So in this example, I have a matrix. Let's say I call this matrix A. And it has values 1, 2, minus 3, minus 10. And I have a matrix B. And matrix B has values minus 7, minus 1, and 5, and 10. Now I have to first find what is A plus B, and I also have to find what is A minus B.
Okay.
So for this I write here A plus B.
It's minus 7.
It's minus 7, thank you. And now I have to add corresponding entries. This entry is at location first row and first column. I add this entry with this entry because this in the matrix B, this entry is at location first row and first column. What is the location of this entry in the matrix B?
Second row and second column.
Second row, second column. And so I will add this entry with this entry because these two are the same location in different matrices. So now I add 1 with minus 7.
1 minus 7.
2
minus 1.
Very good.
Then minus 3 plus 5.
Very good. Minus 3 plus 5.
Minus 10 plus 10.
Plus 10. Now we can solve this. So what is minus 1 minus 7?
Minus 6.
So it is minus 6. And what is 2 minus 1?
1.
It is 1. What is minus 3 plus 5?
2.
It is 2. Very good, very good. We always have a sign of the larger number. What is minus 10 and 10?
0.
0. So that is our answer. So that's the result of A plus B. Now let's quickly do A minus B also. So instead of doing this in this small space, I'm going to reuse this same space. Right? So instead of plus, in this case, we have minus. So here we have minus. Instead of plus, here we have minus. And now we have to redo this second step. So now let's write these entries. We have 1
plus 7.
minus 7. So we will do the plus. You're right, it's 1 plus 7. But don't skip steps so that everybody can understand. So we will have 1 minus 7, which will be 1 plus 7 because minus is plus. Okay? And then we have here 2 minus
1.
So this is like 2 minus 1. You are correct. And here we will have minus 3
minus 5.
minus 3 minus 5. Yes. And here we will have
minus 10 minus 10.
minus 10 and minus 10. Now let's solve this matrix. What we have here is 1 because minus, when you say minus and minus, then answer is plus. So it will be like 1 plus 7.
Yeah.
What's the answer going to be? 1 plus 7?
Plus 8.
Plus 8. So it will be 8. And what's the answer will be? It will be like
Also
2 plus 1.
So 3.
3. And what is the answer of this? Now we have,
We also plus here.
so because we have both sides the same, so we will be add it, right? So
3 plus 5, 5, 6, 7, 8 minus 8.
we will say 8 because we have both sides the same, so we are adding them. And now we will always have the sign of the larger number, which is minus. So answer is going to be minus 8. So what will be the answer?
Minus 20.
Minus 20. Very good. So now we have learned how to add matrices and how to subtract matrices. But you can see, because we are adding corresponding entries, therefore to add two matrices or to subtract two matrices, we must have same dimension of the matrices. Like for example, if we have a matrix A and its dimension of 1 by 3, and we want to add matrix A with matrix B, and B also has dimension 1 by 3. So we can obviously add these matrices because they have same dimensions. But in contrast to that, if I have a matrix C which has dimension 2 times 2, and I want to subtract from matrix C matrix D which has dimension 2 times 3, then I cannot do that. This is an illegal operation because these two matrices have different dimensions. So do you have any questions about addition and subtraction of matrices?
Nope.
So now let's do multiplication of matrices. So I will clear the board and then we will do the multiplication of the matrices.